Thanks for coming. I'm going to give a little bit of talk on Catalyst. I'm going to start off with a bit of an introduction. We have a smaller room today, so it'll be a bit more fun. My name is Jintao. I'm the technical lead at Catalyst. I got into crypto around 2018 as like a market participant, bag held all the way down, and got more involved in 2020 as a DAO contributor and DeFi enthusiast. So I've kind of played with all the protocols, all the chains. I've been all over the place, really just in the weeds, and now working on building Catalyst. So let's go ahead and get started with talking about a bit of a problem that we see moving forward. And that problem is going to be the need to like reimagine infrastructure for the modular future. But what kind of is the modular future? And the best way I have to answer this question is to take a look at the past, and more specifically the period of time from 2020 to 2022, where we kind of saw the number of alternative layer 1 blockchains kind of really take off. And people were kind of deeming this time period, like the multi-chain future. Vitalik says the future will be multi-chain, right? And so more recently, we've seen blockchains being developed against the modular blockchain stack, an example of which being Base. And so currently we're looking at having around 900 chains in the ecosystem right now. But as the modular blockchain stack picks up and more chains are starting to come online, we're seeing a future where we're going to progressively move to potentially millions of chains. But how is that possible? Well, it's possible because it's enabled by the modular blockchain stack. Using rollups as an example, like a rollup only really needs to care about its execution environment while delegating settlement and data availability to its parent chain. So this makes it much easier and much quicker to kind of take your chain from idea to reality. And so the number of chains we should see will probably start to take off over the next couple of years as these things kind of gain more traction and more adoption moving forward. And in fact, so much so that it's very possible that every application will have its own chain. You've probably heard of this. Some people call them app chains. But the nice part about this is that let's say that you're running, for example, let's take GMX as an example, but maybe more generic one, an app chain that is focused on a decentralized perpetual exchange. You may be more interested in having that chain prioritize high availability, low latency, high throughput. And maybe that's not as important for a chain that is focused on specifically NFT transactions or borrowing and lending or whatever your chain may be focused on. And so that's a really nice thing because as you are able to kind of configure and customize these chains for your application, you're able to get the trade-offs that you actually desire. And that sounds great, but it's not all great. Because in this world, there are some problems and things are going to break. And we have to be cognizant of that. We cannot just ignore that fact. And one of them is that we're going to lose connectivity. As all of these chains come online, in the current state of things, there is not necessarily any specific one standard, and the connectivity between the chains will start to degrade as the number of chains really takes off. There's custom implementations to make these chains talk to each other, and these kinds of things don't really scale well as you move into an order of magnitude more chains, right? Furthermore, we've been taking composability within chains, I guess not for granted, but as a really important piece of the puzzle, as things have moved on. And examples of this are, we see it start in 2020, where you have projects such as AlchemixFi building on top of a urine vault to make a synthetic, stablecoin, and all of that can be done atomically. Via these DeFi Legos and composability. This kind of property doesn't really exist so much in this app chain future. It's not really possible to kind of atomically make these transactions across several app chains. And so the composability that we once enjoyed kind of falls off in this environment. In fact, we can even say the same about the infrastructure that's available. I don't know how many of you in this room have kind of aped like a new EVM chain, and the first thing you realize is there's no Etherscan clone, and you have no idea what's going on. You can't read the code, you can't read the transactions, it's completely a mess. And this is going to apply to more and more of the infrastructure stack as we start to see more chains come online, such as wallets, indexing solutions, even governance solutions, RPC nodes. These kinds of things are pain points for what I would consider a lay user, and even as an advanced user, these things can become tiresome, especially with things like really important infrastructure like block explorers that you really do start to feel the pain points when you're missing the one that you are super familiar with. So the question is okay, so you've just given me a bunch of problems, but that's not really helpful. So how can we build for the modular future and for this potentially millions of chain future? Well, there's kind of really three main tenets that infrastructure should be following in order to kind of fit into this new future and really excel in this new future. And the first of which is automatic, right? These infrastructure need to be able to integrate to new chains as they go live or as quickly as possible post-launch. So as I just mentioned in the current state of things, an example being MetaMask, right? When a new EVM chain comes on, there's no MetaMask entry for that chain. There's no RPC anything. And if you're a savvy user, maybe you're able to find that chain, go to chain list, add that really quickly, and you're able to use that chain. But that's not everybody, and most people are, they look at add custom RPC to MetaMask and they just close it. I don't know. And so in the future, we would like to see things moving towards more of how this product called Celestia Scan works. I believe it's been renamed to Modular Cloud. But essentially, when a new rollup is launched using Celestia Modular Blockchain SDK, this is able to be picked up immediately by their Explorer and easily available, kind of using the same interface. And so that really tackles the problem that we just addressed. Furthermore, infrastructure should be permissionless. There shouldn't really be any gatekeeping to putting this new infrastructure on a new chain. The number one example, just in recent history that I can think of this, is the move of Uniswap v3 to the Binance Smart Chain. There was a really big drama over this and a whole governance fiasco. And ideally, your infrastructure shouldn't be gatekeeped by that kind of thing. In fact, in the future, it should be such that anybody can permissionlessly, add into your infrastructure and deploy it on their chain and benefit from that infrastructure while integrating into the existing infrastructure on every other chain as well. Finally, infrastructure should be extensible. As I mentioned, we're going to have many, many new environments, and so your infrastructure needs to be able to expand and support those environments quickly and easily. In the current state, it's not necessarily the case. You have different EVMs, messaging schemas, what have you. And as an application developer, you can definitely feel this pain point. If you were ever trying to create an application that spanned Cosmos in the EVM, tool sets are completely different. The infrastructure available is not the same, and these things just do not work the same. It's almost like learning a completely different set of skills. So in the future, we would prefer for there to be shared standards across these infrastructures, and so that environments are able to more seamlessly integrate, and the development experience itself is also just better because you're working with something that is standardized across all these chains, and you're able to actually kind of make progress rather than reinventing something for every new chain you're working on. So to talk about all of that, I'd like to address how Catalyst is kind of actually addressing these three tenets. And so we'll start with automatic chain connections. Catalyst aims to have pre-compiled contracts on these new chains that are spun up by modular blockchain SDKs, or potentially have a module within that SDK that makes it very easy to have Catalyst on your chain as close to deployment as possible. And so when these chains come online, your chain is automatically connected to the Catalyst liquidity network and is eligible and available for having value transacted against it. That doesn't necessarily mean that it will have value, because as we move on, that's for anybody to decide if there will be value transacted, because the creation of these cross-chain pools is done in a permissionless way. So as soon as somebody says, hey, I want to put some ETH on ETH on ETH, and let's just say I'm using a Polygon modular chain and I want to put some Matic on there, as soon as I've done that without asking anybody and launched this pool, now value can be transacted from Ethereum to the Polygon modular chain without any governance needed, and that value can now flow freely. So kind of an example of this, using something a bit more abstract rather than just this Polygon modular chain, is that if you need to bring liquidity in you don't have a bridge. Now you have a way to transact value into your chain. Finally, we have an extensible protocol design. At its absolute core, Catalyst itself is just a mathematical library, and I'll get a bit more into that in the next couple of slides. But what that means is that there's kind of a reference implementation or a way to verify that the implementation of Catalyst is in fact correct, and therefore Catalyst is language agnostic as well as virtual machine or execution environment agnostic, so long as the implementation adheres to the specification. So that really is pretty powerful, and it allows us to deploy Catalyst in any environment that may, essentially want it. So a bit about how it works. Before I kind of get into this slide, Catalyst is an AMM. It is a mathematical library, and because of that, it employs many of the same properties you see in AMM within a single chain, using, like, let's say Uniswap, for example. I'm sure many of you are familiar with the fact that Uniswap has a price curve, and that price curve determines, as assets come in and assets come out, the amount of assets to take in and give back to the user, and that action moves the price curve in either direction depending on the swap. So, very similarly, this kind of behavior has been implemented in Catalyst, but it is done in a multi-chain way. So just taking a look here, if I was to use the same example as I had in the previous slide to move ETH onto the Polygon modular chain, it would look very, very similar. And in fact, I'll touch on a bit of what we just heard in the previous talk regarding escrow, is that when a user sends in their tokens to the Ethereum chain, their tokens go into an escrow, getting ready to be released inside the pool once their transaction has confirmed. So let's say, okay, I've sent in my ETH. Now this is where the mathematical library comes in, as well as IBC or any kind of arbitrary messaging protocol. Essentially, the mathematical library calculates how many units of liquidity that ETH or that value which has been transferred in is worth. And a unit of liquidity is kind of the big thing that Catalyst is bringing to the table here that's new. And that is the amount of, or essentially the result of an integral which is calculated based on that price movement along the curve from the original transaction. And that unit of liquidity can then be messaged to the other chain and recalculated using the exact same integral formula on the other side to move the price curve again along that curve on the other chain and derive the resultant matic on that chain that is represented by those units of liquidity. Cool. So let's go ahead and take a look at a demo really quick on how that works, and then we'll have time for some questions afterwards as well. Cool. So this demo, really quickly, I'll play it, but this demo is actually our testnet that we currently have running. It's deployed on the Sepolia chain as well as Mumbai. Currently, this demonstration is using only a singular pool, and one of the things to note about Catalyst is that the paradigm of pools within AMM has actually changed a bit. I like to think about it a bit of like a balancer, a multi-chain balancer in a way, where if anyone's familiar, a balancer essentially has one large vault where all the tokens are stored, and that is like kind of where their pools live. For us, our pools are natively multi-chain, and so the concept of a pool is actually an aggregation of vaults on multiple chains, and those vaults may, very similar to Balancer, have multiple tokens within them. So in this example, we have one pool with two vaults, one on Sepolia, one on Mumbai, and each of those vaults has respectively two tokens in it, both very imaginatively named, 1 and 2. So let's go ahead and get into this. Cool, so I don't know if it's actually playing. It is. Okay, so what I was doing here was I was attempting to select, is it playing? Okay, yeah, I was attempting to select the tokens, and I was demonstrating that these tokens are there. So I'll go ahead and select token 1 on the Sepolia network, and then select another version of token 1 on the Mumbai network that I want to kind of transact. And when you hit this max button, or you put in whatever quote you want to do, I'm going to go ahead and pause it really quickly, because unlike most traditional AMMs that exist in the space today, where it's very easy to quote on-chain, this process actually requires generating a quote from both chains involved. And so because of that, it requires some custom off-chain calculation. So this data is derived off-chain from multiple RPCs with all the chains which are being transacted across. So a lot of this is just demonstration data. Obviously, these tokens are worthless. But once we actually do hit swap, what happens in the background is that the tokens are sent in, as I mentioned, and an IBC relayer, or essentially a mock implementation of one, is used to actually check the chains and look for these transactions, right? So Sepolia took a little bit here, so I'm going to skip through it. But you can see that once the transaction has gone through and the tokens were actually sent, I was able to see in the relayer that the hash for that send was received. The execution of the transaction on the Mumbai network was sent, and we'll see that in a second here, where you can actually see that, and I had done multiple swaps on this, but you can actually see that we've received the appropriate amount of token 1 within the Explorer. And then as soon as you do that, you're able to go back into the application and actually go back onto the Mumbai network and verify that you have received these tokens. So the application is currently very early stages. There'd be a lot more nicer UX tracking, things like that. But that's where we're at. And yeah, so if anybody has any questions, happy to field them. But that was our first demonstration of a cross-chain swap from Sepolia to Mumbai.
We have that for the end of the event. So please.
What's the average time it takes, like in this demo? I think I saw a symbol to 3 to 7 minutes. Is that?
Yeah, so that's for this. It's just demo data. It's just whatever. This transaction itself took about, I think, 45 seconds. But it's really going to depend on the chains involved. Something like ETH, if let's say you submit your transaction and the gas prices are really high, or you're transferring to ETH and the gas prices are really high, it can take longer to kind of have that happen, or even just just congestion, various reasons, like block times on chains. Sure. It's gonna impact and vary greatly. Yeah.
And in terms of extensibility, so you're using IBC for Cosmos native chains, and then what about EVM? Are you using like Polymer?
It is. Polymer is definitely one of the solutions they're looking at. It's like so far one of the ones that's targeting EVM. So things we're looking at, but to be absolutely impartial, it's just an arbitrary messaging bridge. And if there is one that supports the EVM, that would be one that we would want to use. Okay. Yeah. So definitely something to look at. And Polymer is on our radar.
Got it. And so is there an element of smart liquidity routing, or is this just composability play where it's like, I want to move these tokens to? Yeah, so
currently in this particular example, there is no smart liquidity routing. That's actually something that we're working on right now, is actually just having a conversation on this morning. Okay. So that's the problem we're still trying to solve, but with multi-hop IBC and things like that, it's going to enable a bit more of creative routing and finding better liquidity paths across many pools. And when you kind of move into the Cosmos ecosystem, that kind of gets a little bit nicer because you have some more native features there. Right. And so yeah, but definitely something we're exploring and trying to work on right now. Yeah.
Excellent.
Yeah.
Can you talk about the unit of liquidity? What's the advantage of building it that way versus like a traditional?
Yeah. So so I'll speak to this, and I'm definitely not like the absolute expert in there. That's definitely better questions for Alexander. But I guess the reason that we really need the unit of liquidity is because when we are generating these quotes and the assets are actually moving across the chains, the general way that you're making these derivations of how much tokens that you should be receiving, you're actually able to calculate atomically on one chain in and out. And so you actually know how many tokens that are there on that chain, right? So when you're trying to generate a quote on a singular chain without the knowledge of the state or the tokens in the other chain, you can't really generate saying, oh, I'm going to get this many tokens back out. So what's easier to do is actually to say, okay, well, this many tokens are worth this many units of liquidity. Essentially, the integral under the curve has been removed. So we need to remove essentially that same area, from the pool. Back into the other pool, if that makes sense. I'm not sure if I answered your question. It's kind of a bit abstract, but essentially, units of liquidity allow us to abstract the idea of value, if you will. Yeah. All right.
One more question.
Sure.
Are you tapping into existing liquidity pools in the interchain, or is there an element of you'll need to bootstrap?
Yeah, so Catalyst itself is an AMM, so it's going to have all of its own liquidity pools. In fact, in this demo, I don't actually touch on it, but there's that second tab pool, and so there will be liquidity pools, and liquidity pools, as I mentioned, will be natively cross-chain. So it's a bit of a different experience and very divergent from other AMMs that we've seen, because when you're actually providing liquidity, you have the optionality to provide liquidity on all chains within the pool at the same time. So, yeah. All right. Thanks, everybody.